Alright, I'm gonna show off some migration in this video for Boss, and we'll be moving this server here. It's running Bamboo, which is like a CI. I like it a lot better than Jenkins, but it's still Java and it's memory hungry. So I currently have it on this server here, but this server only has 7 gig of RAM and a couple cores, and I've recently moved things off of this node, and it has a lot more RAM, a lot more cores, and it's faster, so it's a much better server for doing CI and builds and testing. So we'll be moving that. And so recently I added some checkpoint and restore in Boss. So if we look at the agent code and go to checkpoint, here what we do is you can make a checkpoint request, and what I wanted was I want to have a registry, so I'm running in the open source Docker registry, and then what I'm doing is I'm creating checkpoints as OCI images. So I have a index here, which this is the types from the OCI image spec, and so I'll create an index, and or this is also called a manifest list because it has this list of manifests, which are descriptors. And so within this you can define your own media types, you can add other image indexes or manifest as pointers, so you don't have to push actual content and things like that. So what I'm doing is I'm taking this index and I'm persisting any state to it that I want to be had in a migration. So I load the container from containerd, and then I get that container's information, and then I marshal that to JSON here, and after we have that as JSON, I have a new reader, and then what we need to do to kind of build out an image by hand is we have to write this content to the containerd content store, and when we do that we'll get descriptors back. So first off, we can look at my media type that I defined, and you can use existing image media types or you can make your own, which is really nice. I think a lot of people don't know how powerful the image spec is and everything that's been done within containerd and content handling, stuff like that. So I have my own media type for container information. If we look at this write content function, all we're doing is getting the containerd content store, we're copying our reader here into it, and we're using the content stores writer, and then when we do a commit we can get the writer and the size that we copied and create a descriptor from that, or after we commit we can get the digest of that content that was ingested in the containerd content store. And with that descriptor, for a checkpoint we're probably constrained to OS and Arch, so I'll add additional platform information on that, and then I'll add that descriptor to our index here. And then after that we have any live checkpoint options. In this video I'm not going to do live stuff. We're still working out some kinks, and I had issues on Ubuntu 18.04 with IP tables for a while, so I'm just going to do a kind of cold migration of container state. But yeah, so I have heading down, I have this method pause and run, so it's basically so I can do atomic operations. It'll pause and resume the container after these operations are completed. So next thing we need to do to add to this index is get the RW layer for this container, so any state that the container has. And it's actually, like, everything's so easy with containerd and the way we have this built out. So we create some diff ops, we give it a reference, and then we call the rootfs package create diff. We give it the container snapshot key, the snapshot service with what snapshotter we're using. I'm using overlay. And then we give it the containerd diff service and any options, and what we get back is this RW is actually a descriptor where it wrote the RW layer into the containerd content store and got us a descriptor back. So I add that platform information again, add that descriptor to the manifest, and then here is for the live checkpointing, which I'm not gonna do, but it's basically if I pass the live flag with boss, it goes to the task service and does a checkpoint and returns the descriptors back for the live memory state and things like that for the container, and we can add those just like everything else. And then finally at the end we kind of have our index built out. So there's this write index method, which we need to add some content labels here so that it doesn't get GC'd. We marshal this index and then we write it like any other content like we did before. And this media type is from the OCI spec, so it's an OCI image index. And then after we write that index, we get the index descriptor, and we can finally create our image. So we have a reference that I'll provide on the checkpoint, and then the image target is that descriptor of the index. And then we have this little image metadata object. We go to containerd's image service and tell it to create that. So now we have an actual image. And then if I wanted to stop this service at the end of this checkpoint, we stop it and we're good to go. So basically on the other end, after we checkpoint something, we'll push this image here, since we have an actual image of this checkpointed data with RW and any other domain specific stuff we add to it. On restore, we get that back, we pull that image as our checkpoint from the ref, so we either have it locally or we'll fetch it. And then we need to take that image and decode the index back out, so we get our OCI spec type. And then from that index I basically just do fetches based upon the media type. So give me this manifest so I can operate on it. So I get out my custom media type of all the container information. We can read that blob out of the content store, because these descriptors are just pointers to content. And then I get my container back. I get my boss config out of that. I can pull the original image from within that config now to get the image on that machine. And then I start building out my new container ops, where we'll still give it a new snapshot from the image and the config. And then if there's any live data, we'll add that. But we create the new container that will give us a new snapshot on that container. And then we need to apply the RW layer, so I get that descriptor. And then it's really easy, just like checkpointing the RW. We get mounts for our snapshotter for the container, and then we go into the diff service again and tell it to apply this RW descriptor on top of these mounts, and that's basically it. So this is just boss stuff here, writing configs and starting the service, and we're done. And I have another API that kind of just handles all this checkpoint restore push migration for us. So let's go ahead and migrate some stuff. So on node 3 here, I have my Bamboo container. It's using over a gig of memory. I think it's actually using even more. And it has a RW layer of about a gig. And this node is also running my registry. So you need a registry master for this stuff because it has the OCI support. And then finally on the other side, node 1 has nothing, and this is what we're migrating to. So before we start this, I need to get build kit on node 1. So let me SSH into this. Wrong machine. Okay, so I'll go into my boss toml here, and oh no, that's not it. I need to add build kit image equals docker.io Crosby Michael build kit latest. All right, and then we'll do a sudo boss init, and I only want to run the build kit step to get build kit on this machine. Alright, so we should have build kit running, and we do. So let's migrate Bamboo over. So I'm on my local machine here, so boss migrate sh. Let's migrate, I can't spell. So here's all the settings. So boss list, we're going from 3. So migrate, I want 2. We're going to 01 node.ages. 1237. Okay, we want to stop the container after a checkpoint. The ref will be our registry path, and we'll call this Bamboo migrate, Bamboo migration. It's not live. I don't want to delete it on node 3 yet. I want to make sure it checkpointed fine, and then we say we want Bamboo. That looks about right. From 03 migrate to 01, stop it. Here's the ref, go. So this should checkpoint this, push it to that local registry, and then stop it on 03 and start it on 02. And when we see this running here, if I refresh console, after it gets stopped, the Bamboo service should go into kind of node maintenance, but we'll see. So since it's a gig, it may take a little bit to tar up, but the network transfer should be pretty quick. Alright, so that migration took about a minute or so. If I run list here on node 3, we should see Bamboo is stopped here. And then if I run list on node 1 now, we should see that it's up, it's running. If we go to console, we have Bamboo on node 3 is felling right now. Bamboo node 1, it'll take a couple minutes to boot, and then the health check should come up and be fine. So we'll wait for that health check to get up and running, and then I'll try to to see this. So yeah, it's still booting. It's slow. So if I go to node 1, refresh this, we can see it's working. So I'll pause this again and we'll see this when it's back running. Alright, so it's up over here. We should be able to refresh this and log in again. And then we can do some cleanup on node 1. So there we go. It's back, it's running on the new node. I need to do some cleanup. So over here on node 3, I want to take build kit off of this one. So sudo boss init undo, and then this step build kit works on this as well. It'll tell us we're removing build kit and removing the registration. We'll say yes. So let's do a status build kit. It stopped. And then I want to remove this out of the toml file. Okay, so let me check that build kit is also removed. Bamboo is fine. Where is my build kit? Where is it? Ah, here. It should have been removed from 03. Why? Alright, I need to work on my unregistration. So curl-x put we'll just deregister this manually. What's the name? Okay. So that should get rid of it. Alright, we're good. Okay, so finally, I think that's it. If we look at memory over here, we're good. So boss list and boss delete bamboo. We'll delete it on node 3 and we should be good. And if we go back to console here, we should see our bamboos cleaned up and we're good to go. So that's kind of migration in Boss and how it works. Basically, you set up a registry. We checkpoint as a manifest list with images, and it's pretty seamless.